Do asteroids in our solar system have anything in common with a galaxy 30 million light years away? What did NASA's Lucy spacecraft discover on its way toward Jupiter's Trojan asteroids? And do you really need to drive dozens of kilometers away from the city to photograph one of the brightest galaxies in the spring sky? In theory, no. Yet every spring, amateur astronomers load their telescopes into their cars and escape the glow of streetlights to aim them toward the constellation of Leo. And is it actually possible to track asteroids from the suburbs using an amateur telescope? Let's find out. Today we are traveling from our own solar system to a galaxy whose light began its journey toward Earth when the earliest ancestors of modern primates were just beginning to emerge. So buckle up and let's head toward NGC 2903. Constellation Leo is one of the most striking sights in the spring sky. Its brightest stars point toward one of the richest galaxy fields visible from the northern hemisphere. Among them, there is NGC 2903. In a single 3-minute exposure, it may not look particularly impressive, but stack several hours of data together, and the galaxy begins to reveal its true beauty. Add 9 hours of hydrogen alpha data and suddenly we can see where new stars are being born. NGC 2903 is a barred spiral galaxy located about 30 million light years away. It's so bright and prominent that, had it been discovered a little earlier, it might have earned a place in the Messier catalogue. The light we are seeing tonight left this galaxy when the earliest primate ancestors were beginning to spread across Earth. The galaxy spans roughly 80 to 100 light years in diameter, comparable in size to our own Milky Way. In many ways, we are looking at a system remarkably similar to our own. Its central bar acts like a cosmic highway, channeling gas from the outer regions toward the galactic core. As more gas accumulates in the center, matter becomes increasingly concentrated. Eventually, gravity overwhelms the forces resisting collapse. The gas clouds begin to contract under their own weight, forming protostars and later young hot stars. Their intense radiation ionizes the surrounding hydrogen gas, creating the bright red regions visible in long exposure images. Dark dust lanes cut across the luminous core while the spiral arms stretch outward. They aren't perfectly symmetrical. One appears richer in bright star-forming regions than the other. This asymmetry hints at the galaxy's dynamic history, perhaps shaped by past gravitational interactions. With enough exposure time, another galaxy emerges in the same field of view, UGC 5086. Unlike NGC 2903, this is a low surface brightness galaxy. Its light is spread across a large area. It lacks a bright central core, and its surface brightness is often lower than the natural glow of the night sky itself. That's why light pollution almost completely erases it from view. UGC 5086 is believed to be at roughly the same distance as NGC 2903, about 30 million light years away. The space between them is estimated to be anywhere from a few 100,000 to 1 million light years. Low surface brightness galaxies are especially interesting because they often contain unusually large amounts of dark matter. They have fewer stars, experience slower evolutionary processes, and form new stars at a much lower rate. They follow a very different rhythm of cosmic evolution. But the real depth of this image becomes apparent when we notice a third object. A distant galaxy from the leader catalogue appears to belong to the same group. In reality, however, it lies around 467 million light years from Earth, more than 15 times further away than NGC 2903. The light we are seeing from this galaxy began its journey long before complex life appeared on land. So within a single image, we are looking at two very different layers of the universe: our local galactic neighborhood and a distant background nearly 500 million years in the past. Now let's change scale completely. Instead of millions of light years, let's talk about hundreds of millions of kilometers. NGC 2903 lies close to the ecliptic, the path of the planets across the sky. As a result, asteroids from the main belt between Mars and Jupiter often pass through this field of view. These are small rocky worlds, ranging from a few meters to hundreds of kilometers across. On cosmic scales, they are practically next door. In a single image, we can capture a galaxy 30 million light years away and a rocky object orbiting within our own solar system. This is exactly the kind of contrast that many astrophotographers love. Under dark skies, even a small telescope with an 8 cm aperture can record the motion of an asteroid drifting across the background of distant galaxies. But can we do the same near a major city? This time, instead of an 8 cm refractor, we are using a 30 cm Newtonian telescope, but under far brighter sky, just 20 kilometers from the center of a 500,000 population city. The result? See yourself. Millions of light years versus just few light minutes. Hundreds of millions of years in the past versus almost the present. Almost, because even the asteroids image still takes several minutes to reach us. This is what the detected asteroids look like after several nights of imaging. If we continue down the asteroid rabbit hole, we travel even deeper into history. Among these objects are Jupiter's Trojan asteroids, which share the planet's orbit around the Sun. In 2023, Lucy flew past asteroid Dinkenesh and discovered that it was accompanied by a small satellite. In 2025, the spacecraft passed asteroid Donald Johnson, returning detailed images that revealed it to be significantly larger and more complex than expected. And this is only the beginning. Lucy is ultimately heading toward the Trojan asteroids themselves, objects believed to be relics of the early solar system. Studying their composition allows us to look back roughly 4.5 billion years to the era when the planets were still forming and Jupiter was migrating through the young protoplanetary disk. And suddenly, three completely different scales come together in a single story. 30 million years, the time it took the light from NGC 2903 to reach us. Hundreds of millions of kilometers, the distance to asteroids in the main belt. And 4.5 billion years, the history preserved within the primordial bodies Lucy is exploring. That's why traveling to dark skies isn't just about aesthetics. Within a single field of view, different epochs and different scales of the universe meet. And perhaps that's why we still pack our telescopes into our cars and drive where the city lights finally fade away. In the next episode, we'll take a closer look at one of the most spectacular events visible in our cosmic neighborhood, a collision between the two galaxies. And while those galaxies were colliding, Earth was going through a catastrophe of its own, an event that wiped out roughly 75% of all species. Today we have a chance to look back and see what that distant region of the universe looked like at exactly the same moment in time.